perspectives in this domain. At first, the end-to-end graph neural network. As we mentioned, the current works in the literature have used the transfer learning method to recommend the theme, and in this way that at first the embedding vectors, the dense vectors for the skill nodes are learned by some representation learning method separately, and then we feed it to the recommender. And the idea is that making these two separate methods together in a way that instead of separately learning the dense vectors, then feeding it to the neural net, using and applying an end-to-end literature architecture in a way that by a GNN method, the embedding vectors learn, and then by looking at the problem as an edge prediction task, the connection between the expert node and the team nodes are predicted. In this way, in this end-to-end method, we expect that we get the better results, and we can say that this research started in 1 year ago, and we have some initial promising results, and we can this data, these results that the end-to-end results in compare with the transfer learning base, both for VNN and FNN, have improved, and this end-to-end method is in the first steps, and we target to submit our initial result in Stigaira.
Hopefully.
Yeah.
Just before that, this is just the result. I mean, I told you so. So you can see that. I mean, before end-to-end platform, I mean, majority of the results are just 1 point something, and again it's percent. But then after the end-to-end architecture, you can see that there is a huge improvement in the results. So I mean, we believe that we are on the right track. So you can see that, for instance, the recall at 5 is about 54% compared to the existing method is just 1.3%. This is one thing about efficacy. About efficiency in terms of the speed. So in the previous architecture, you have to just learn the GNN for some amounts of epochs, and then you just collect the embeddings of the skills. You have to do another training of feed-forward neural net or Bayesian neural net for another set of epochs. So two separate training phases, and again, in terms of the time, it takes a lot of time, computation, etc. But here, we just try to, on the same graph, we reformulate the team recommendation as an edge prediction. We could simply say that if I wanted to form a team T that has the skill S, so I just have to predict the links between the expert to this single team T. So it becomes a link prediction. So there is no multi-label classification. There is no issue of very large apple layer. There is no issue of, negative samplings, etc. And in future, we can easily add other objectives, because the GNN methods are based on attributed graphs. So attributed graphs are just attributes on nodes. So right now, it is just edge prediction on nodes, and these nodes has no features, but later we can add features. For instance, the location of the experts, about the skills, the importance of the skills, and etc. So we can easily extend this end-to-end approach to consider other objectives. So it improves the results, it improves the speed as well. Yeah, just one. And again, the initial result, we can see that some rows are still empty because we are still running. But so far, the same GNN methods that used in an end-to-end architecture works way better compared to when we use it just to learn the embeddings of these views and then feed it to another FNF or BNF. So end-to-end approach is just straightforward, and yeah, that was just a quick note. Oh, yes.
Okay, after it, the other challenge that we want to mention is about recommending fair and diverse teams. As we know, the primary focus of existing works in team recommendation domain, has been improving the efficacy, and it is mostly focused on the effectiveness, and so they mostly ignore the diversity and the fairness about selecting the experts. And fairness in machine learning algorithm usually guarantee that disadvantaged group, for example, if you compare male experts and female experts, we can say that we can consider female as a disadvantaged group, and we also we can name them by protected group. And by fairness in machine learning, we expect the model, to add disadvantage and advantage experts, similarly. And there is little or no diversity-aware algorithms in team recommendation domain. And if we want to, look at this, we need to, maybe focus on different notions of group fairness. For example, demographic parity and equality of opportunity. And we expect the model, consider these fairness notions, in recommending the team. By demographic parity, it means that when we have a distribution, for example, 70 to 30 in the candidate pool, we expect that in the predicted team, in the final team, the same percentage, is satisfied. This is the meaning of demographic parity. And if we want to formulate this, we can say that the probability of membership of male and female to a team would be equal, and also the probability of not being a member of a team would be equal for male and female experts. This is, the formulation of demographic parity, that should be considered by the machine learning algorithm. And the other notion we want to talk about is the equality of opportunity. It is similar to demographic parity, but the difference is that by equality of opportunity, the focus is only on the qualified experts, not on all of the experts. From the pool, suppose that 50% of skilled experts are female, and 50% of the skilled experts are male. So we expect that in the predicted team, we have the same percentage. And if we want to formulate this, the formulation would be in this way: the probability of the membership of skilled male and skilled female to a team would be equal. In this way, we can say that the equality of opportunity, has been satisfied. In general, the Bayesian algorithm can be categorized to pre-processing, in-processing, and post-processing. In team recommendation domain, we can say that to the best of our knowledge, there isn't any work that focuses on the pre-processing, method to tackle the problem. But there is little work, that try to recommend the fair team by in-processing and post-processing methods. In pre-processing methods, the focus is on modifying the data before applying the machine learning algorithms. And in processing methods, these methods try to modify the loss function in a way that meanwhile the process of recommending, by modifying the loss function, the output would be fair. And we can say that, for example, the loss function in this method, can be designed in a way that the model, the loss function penalizes the model when a predicted, expert randomly, selected from the male experts. When the prediction is incorrect, incorrectly, an expert incorrectly selected male instead of female, then the model, is penalized by the loss function. So, by modifying the loss function, it would be possible to, to force the model to predict, the fair teams by considering any notions of fairness that can be considered, as an example, demographic parity or equality of opportunity, or any other, fairness notions.
I just wanted to add something. So we did this very small experiment. So as Matthew said, it's very, it might look like kind of complex, but the idea is very simple. We say that if the model wants to make a mistake, mistakes means that recommending an expert which shouldn't be there. So if that expert is a male expert, we just simply calculate the normal loss. But if that expert is a female expert, we try to increase the loss hugely. So, decrease the loss hugely. So decreasing means that if that incorrect recommendation is about female, we like it. It's a mistake, but because it's about a female, we are okay with that. Because at the end of the day, the team gonna have an extra female in the team, which is okay for us. But however, if it tries to recommend a male expert, which should not be there, we increase the loss hugely. Meaning that the error about male is gonna be huge, but the error about female, we just reduce it or we just keep it as it is. So meaning that a mistake about female is not that disaster compared to a mistake about a male. Yeah, that was just a quick one.
Okay, thank you. So after, in processing methods, the other method that, we have a little work about it is post-processing methods. In this method, after, recommending a team by the model, a re-ranking method is applied on the output to change the team to a fair one. It means that, by applying the re-ranking method, we will have an output by considering the different evaluation metrics. And in this way that, as you can see, we have the output, and then by comparing two different, notion of fairness, a re-ranking method is applied on the output by changing the, position of the experts in a way that, the quality, the quality metrics, satisfied, but and on top of that, we have the fair output as the recommended team. And it is a post-processing method.
Just one more. Sorry, I just jumped into there. One thing about these two methods, the in-processing method has the power to debias huge biases. If you're in your data set, there's a huge bias toward male, and there's very few female, you cannot fix it by pre-processing or post-processing. In-processing works better. But the problem is that you have to adjust the loss. You have to change your model, you have to adjust your loss in your model in order to have the effect. But the beauty of the post-processing is this. You could have any model that does the recommendation. For instance, end-to-end approach, FNN, BNN, whatever method you're gonna have. And then you just simply pick the top K, and then you give it to the post-processing or re-ranking method. So it doesn't depend on the architecture that does the recommendation, so it's totally independent. It just re-rank in order to preserve the fairness. So we could simply call it model agnostic way of debiasing. It's simpler but less powerful. The in-processing needs changes to the architecture but more powerful. Just, the trade-off between the change to the model and the power of the debiasing method. That was all. Yeah.
And the last, challenge that we can mention is spatial recommendation. As Hossein explained previously, it is possible to add, the location of, the desired location of the team to to get the better, results, to be more informative, because the location, matters in most of the times. And for example, working for organizations maybe should be in person, so the location is important. And maybe we say that nowadays by online working, maybe we think that the location is not important, and all the experts can connect together to work online. But in general, we can say that it is important for the expert at least to be in same time zone, because when the working hours of experts is not near to the working hours of another expert, it makes it impossible to jointly work on different projects. So even in the online working, the location matters, and that's why it is one of the challenges in team recommendation domain, to add the information about the location, on top of the skills and the other, in other objectives that we desire to add to predict, the best teams, the best successful teams. In the last part that I'm going to explain, I'm going to mention some potential applications of team recommendation that we can think about to go through them in more detail and get the better results. The first one is the group learning, students group learning. Why the group learning is important? We can easily see that, we can easily think about this, that when students work together as different teams, they have the opportunity to go in depth in different topics, and so they can improve their knowledge, they can improve their communication skills, they problem solving skills. So in general, we can say that group learning for students is really important. But you can see that there are so many groups of students that work together, but it is not successful. And the question is that why we have unsuccessful teams of students. And one of the reasons can be mentioning to this point that when teams are not formed systematically, we cannot expect to lead to success. So one of the important steps is forming the teams systematically and by considering different important attributes and conditions. In general, traditionally, usually the student teams are formed based on the average grade that they get, based on their availability, or also based on their behavior and their personality, and we can find different methods in social science that can help instructors to consider only the behavior and the characteristic of the students to form them as a team. But it is not enough in general, and in this study, if we we focus on the peer works in group learning works, we can see that the majority of works have used integer linear programming or the generic algorithms to seek the teams, the student teams to work together, and the tasks that they usually focus on can be categorized to, as you can see, resource allocation or matching the students based on their skills, or task assignment based on the the capability of the students, and also the project allocation. These are the tasks that have been considered by previous researchers, but they try to solve by, as I mentioned, integer linear programming or the genetic algorithm. If we think about the team recommendation, it is suggested that look at this problem as a team recommendation problem, and by forming the network at first based on the previous grades, previous result of the students, it can easily it would be easy for the universities or for the schools that in time have the results that help to generate such network, and then applying different team recommendation algorithm is possible to recommend the student teams with the highest probability of successfulness. And especially nowadays, in large-scale classes, large-scale online classes, it is really crucial to think about this systematic forming and recommending student teams, because in large-scale classes, it is not possible for instructors to be in touch with all of the students, and it is really crucial to have some methods, and also it is not possible to manually form the teams. So group learning is one of the potential applications that that can be modified, that can be get better results by applying team recommendation algorithms.
I think we have to move quickly because
Okay.
we have only
Okay.
1 hour for January.
Yes. So the other applications, the reviewer assignment, I wanted to mention. As in academia, it is important how we can select the best reviewer for the papers, and this problem also can be seen as a team recommendation problem, and by applying the algorithm it would be possible to tackle to this. And the last one that I plan to talk about, palliative care, which is the method to to help the patient and their families to improve the quality of life, especially for some diseases or some cancers, which is really especially cancer and something like that. And these are the potential applications of the recommendation domain.
Sorry, we have to quickly wrap up the application, and then because we have the hands-on experience on the OpenTF, one thing, can you go to the reviewer assignment? Here the idea is that, how many of you have done the peer review? So perfect. So basically the idea is that you go and pick your topics of interest, and then you see the ranks of papers, and you select which one you wanted to review or not. So you can look at it as a team recommendation, how the keyword of the paper could be the skill. The machine tries to recommend papers to the experts who wanted to review that paper. So it's kind of a reverse engineering of the review process. So we have a paper as a team, but this time we are not going to do that research paper. We want to review that paper. So we are looking for some experts to review that paper. And the skills, the input skills for the machine gonna be the keyword of that paper. So this could be one potential thing. About the palliative care, actually this has been a project in our city. The idea is that there are some people that they are isolated or they are suffering from some diseases. So how can we recommend some other people to take care of these type of people? So it's kind of a matchmaking between people who wants to help and people that are ill. So you can look at it again as a team recommendation. So how can we recommend some subset of care, take care, people who wants to take care to some diseases. So the input is gonna be the diseases or the type of illnesses, and the output gonna be a subset of people who wants to help. So that was another application, and hopefully in future we are going to work on that. And now I think we have the hands-on experience. Yes.
Yes, yes.
So I have to ask Jamil.
Last slide.
Oh, wait a second. So I have to keep this
Yes.
after the.
Yes.
Okay. So now